Okay, so I know you guys love logs. They're everybody's favorite. So today we are going to look at the derivatives of logs and exponentials, and I know you're excited. Okay, so for our purposes today, we are going to start with the derivative of exponentials. Okay, so remember, exponentials are when we have an exponent and then the variable is going to be in the exponent, all right? And the notation we are going to use on these is a to the x, all right? So we have the derivative of a to the x. And the derivative of a to the x is actually shockingly easy. The derivative of a to the x is a to the x times the natural log, ln or ln, of a. Okay, so that seems nice and straightforward. So down here, back to this example, 5 to the x. So if I asked you for the derivative of 5 to the x, it would simply be 5 to the x times the natural log of 5. So easy enough. So let's go write this down somewhere because this is the most common notation that you will see for that. Now, of course, it gets slightly more complex. So that exponent was nice and simple, but a lot of times we'll get something that looks a little crazier, and it might look like, 4 to the 3x squared. So in this case, remember we were just looking at like 4 to the x. So in this case, you can see that what's happening in the exponent is a full-blown function that has a derivative. So 3x squared has a derivative. So the notation we're going to use on that is going to be the derivative of a to the f of x. So I'm not really doing anything differently. I just want you to see that the exponent can be a function of itself. So the derivative of that is the same thing. So a to the f of x times the natural log of a. That doesn't change. But chain rule is going to kick in, and we're then going to need to multiply by the derivative of f of x. All right? So this just has chain rule in it. It's the same thing, it just has chain rule. Okay? So back over here, if I've got 4 to the 3x squared, the derivative of that is going to be, let me make myself a little more room here, is going to be a to the x, which is 4 to the 3x squared, times the natural log of 4 times the derivative of 3x squared, which is 6x. And that's your derivative. Not so bad. Should we try a couple more of those? What if we have, let's write this down so we don't forget. The derivative of a to the x is a to the x times the natural log of a. All right? So let's try another one. What is the derivative of 5 to the 3x plus 4? So again, my 5 is a, and 3x plus 4 is my x. Okay, so over here my answer, I have an x here, an a here, and an a here. So let's go through this carefully. So the derivative of a to the x is a to the x. So I'm just going to rewrite the whole thing. Okay, there's my a to the x. Times the natural log of a. Well, a is 5. So the natural log of 5. Now, chain rule says I need to multiply by the derivative of 3x plus 4. The derivative of 3x plus 4 is 3. That's it. done. Okay, now let's move on to logs. Now remember, a log is an inverse of an exponential function. So logs have the notation log base a of x. Okay, so we're going to look for the derivative of log base a of x. And again, you can find how these were figured out online. You can look up the proof of the derivative of a log function. We're not going to cover that here, but you are more than welcome to look at it. So it's pretty straightforward. I like this one a lot. The derivative of log base a of x is 1 over x times the natural log of a. All right, so if we have the derivative of log base 5, log base 5 of x, then the derivative of that, so hold on, let's color code what we've got. A, x, x. Oh, and this log, natural log goes with the a. All right, so our a in this case is 5, and our x is, well, it's x. Okay, so the derivative is going to be 1 over x, which is x, times the natural log of 5. So if I do that again, the derivative of log base, 12 of x is 1 over x ln 12. Okay, not bad. Now, of course, we're going to make it a little more complicated because these x's are just behaving nicely. But what if we replace our x with an f of x? So let me write that over here. So the derivative of log base a of f of x. So chain rule is going to come into play again like it did last time. So what we're going to have happen is we're going to still have 1. The rule doesn't end. But our x is now an f of x, right? Like it's acting in the blue, just like it was x over here. So 1 over f of x, ln a, that doesn't change. But then we're going to multiply by the derivative of x, or of f of x, because we have to do chain rule. So that means, let's do another example. So what if we have log base 5, like we did last time, but this time we have x squared. So you can see here that our x is now an f of x, right? It's got its own derivative, and we have to take that derivative as well as the derivative of the log. So our derivative, oops, I forgot to write d dx. The derivative of this is going to be 1 over f of x, which is x squared, times the natural log of a, which is 5, times the derivative of f of x, so 2x, because the derivative of x squared is 2x. Now, if you look really closely, we can of course clean this up, right? Because this is like multiplying right here, right? Aren't we just kind of multiplying two fractions? So we can clean that up to 2x over x squared ln 5. And then if you look really closely, we can cancel out. You can almost always cancel something out in these. So really watch for that. So 2 over x natural log 5. And that's your final answer. I would say these are probably the most tricky, only because of that cancel step, but it's not too bad. All right, let's try 1 or 2 more of those. What if we would like to find the derivative of log base 4 of 3x squared? So on this one, remember the derivative, if you need to write these down, the derivative of log base a to the x is 1 over x ln a. All right, so 1 over x, our x here is 3x squared, times the natural log of a, which is 4. Chain rule, take the derivative of 3x squared, which is 6x. Okay, clean it up. 6x over 3x squared times the natural log of 4. Look right here, this 6 and this 3 and this x and x, they can cancel. We can go further. So the 6 over the 3 is really a 2. That x in the top is going to cancel. I'll leave an x in the bottom times the natural log of 4. That's it. We're done. So if you didn't get that, I can leave something for you to screenshot right here. So we have the derivative of a to the x equals a to the x times the natural log of a. And the derivative of log base a to the x equals 1 over x ln a. If you would like to add in the f of x because it helps you see it, the derivative of a to the f of x is a to the f of x times the natural log of a times f prime of x. Okay, and for the log, the derivative of log base a f of x is 1 over f of x ln a times f prime of x. Okay, so this is your derivative for exponentials. And this is your derivative for logarithms. Oh, I lost an M. Okay, there you go. Now you can try it.